Hey, Bogdan here, where we make algebra easy just for you. In this video on quadratic functions, we'll show you intersection of a parabola with a line. So let's dive in. So quick description, we will be working with a quadratic function in general form where you see the equation of quadratic function, and then equation of a line will be provided, and our goal will be to identify possibilities. So when you put those equations together, we'll explain how. Then you're going to create new equation out of that, a new quadratic equation. And based on the possible solutions that you have right here, we will see whether there are points of intersection if the discriminant is greater than 0, one point of contact between parabola and the line, or potentially no points of intersection in the case where the discriminant is negative. So the illustration. So in this little diagram, you have a picture of a parabolic shape. So we don't care what is the actual equation at this point. This is just an illustration. This parabola happens to open down, has x-intercepts and all shebang, not important. But since we have this parabola handy, there are all possibilities illustrated here. Let's look at the green line. Y is equal mx plus b. So that line may not, or in fact, it does not intersect with this parabola. So if we were to put two equations together to create a new equations, that would show you quickly in the process of solving that quadratic equation that the discriminant is negative. So when you have a situation like that, you would understand that there's no point of intersections, and you make that conclusion right away. Sometimes you will have a situation in the case of the red line. That red line, it looks like it's touching parabola at one point. So when you put together this red line equation with the given parabolic formula, you will formulate a new quadratic function, and then you will solve this equation. When you put everything to one side, we'll explain how. You will observe that there is one solution. Discriminant will be 0 in that case, so that this is one point of intersection between those two geometric shapes. So that is the second case. And finally, the third possibility, the line in blue, it seems like there are 2 points of intersections between this parabola and that line. So when you put it together, you create a new equations, and in the process you will see that the discriminant is greater than 0. You have 2 points of intersection, and then interpretation will come along when you work with word problems, and other videos will explain that a little bit better. Now, for this video, we have a pure mathematical questions. Find the intersection points of this parabola x squared minus 4x plus 3 and the line given by the formula y is equal to x minus 3. So since we don't see the question given in the graphical form, there's no picture attached, we know now that we have to put those two equations together. And then the next step of this equation question is find the equation of the line through those points. So we will find those points of intersections if they do exist, and then we generate the equation of the line through those points so that we'll confirm that indeed this is the same line that was given in the first place. So for now, point of intersections. So you put equation of the parabola together with equation of the line. You make them the same. You make them equal, as if you were creating a diagram or a sketch of this function and the function on the same Cartesian plane, and then you would anticipate to show points of intersection. Algebraically, that means you have to solve that new equation by first step. Always organize your work. move everything to one side, typically to the left side, so that you can create a statement that is equal to 0. In the process of shifting terms around, 2x will be put to the left side and -3 will be put to the left side. So here go. You have copy of that first equation. Then you have -2x plus 3 equals to 0. And you start collecting like terms by looking at the question. You have 1x squared, so you bring this down in the line below. You have -4x and -2x, that gives you -6x. So hopefully this makes sense now. 3 plus 3 is 6. So this is the new equation that we have to find solution to. So identify that this is quadratic equation, coefficient A, B, and C, quadratic formula. The most efficient way, use the quadratic formula that always works. And also quadratic formula confirms, because you will be doing the discriminant in the process, if you have a solutions or not. So A is 1, B is -6, C is 6. This is the quadratic formula that you're familiar with. We did already videos on that. So if you want to refreshment, please watch those videos. But right now, focus on proper substitution. So B is -6. So inside the formula, you will see +6 because -6. Plus or minus possibilities. And then inside, there is the discriminant expression, -b squared. So you have to show -6 in brackets squared. Common mistakes students making just right here. -4 times A, which is 1, times C, which is 6. So hopefully that makes sense. And quickly you can identify the value of the discriminant. This is 36 minus 24 greater than 0. So I anticipate 2 points of intersection. So now, solving it in mathematics, you want to show exact value. You don't want to convert into decimals. We'll do decimals with word problems, but right now you do mathematical application. So exact answers are the key. So 6 plus square root 12, because 36 minus 24. And you will have 2 possibilities. So one time you would add, the other time you would just subtract. So before we do that, we can simplify square root 12. Square root 12 consists of a product, 4 times 3, and 4 outside, square root gives you 2, and 3 remains inside. So you transition from this radical into mixed radical expression, and you observe that 6, 2, and 2 all share the same factor. So you would divide this expression by 2 so that you can get 3 plus radical 3 or 3 minus radical 3. So those are the x coordinates of those 2 points of intersection. To find the second coordinate, you use the equation of that quadratic function, or you can use the equation of the line, which is easier to work with. In this case, I use the equation of the line. It's much easier. So the equation of the line was 2x minus 3. So in place of x, you put 3 plus radical 3 one time around, and you do the math. So 2 times 3 is 6 plus 2 root 3 minus 3. So 6 and -3 gives you 3. And add 2 radical 3. Those 2 terms do not converge into 1 because they are distinct. They are not the same terms that you can merge together into 1. And with this root, with this value of x, 3 minus root 3 you put back into the equation of a line. You do the same thing. You do distribute. So you have 6 minus 2 times radical 3 minus 3. So 6 and minus 3 gives you 3 and minus 2 radical 3. So now we found 2 points of intersection, and let's put them together. So point 1 has coordinates 3 plus root 3, comma 3 plus 2 root 3. Point 2, separate point, has 3 minus radical 3 with y 3 minus 2 radical 3. So in order for us to do the equation of a line that passes through point P1 and P2, we have to remember that equation of a line consists of y is equal to mx plus b. So hopefully you remember that. If you want to create that equation, you have to find the slope. Slope of the line is a must. So this is the rise of a run. This is the difference in y coordinates divided by difference in x coordinates. So let's begin with that. Using the y coordinates taken from point P1 and P2, you do the substitution. You put them in brackets because they are separate entities. Y, first one, it is 3 plus 2 radical 3 minus the second y. So put that in brackets first. Then you distribute and simplify. Over the x coordinates, again, since each x coordinate consists of 2 terms, put them in brackets first to show the subtraction. Then you distribute. So, for example, 3 minus 3, 0. 2 radical 3 minus 2 radical 3 gives you 4 radical 3. So that's on top. The bottom part, 3 minus 3 is 0. And then root 3 minus negative root 3 is 2 root 3. And now you can cancel this because radical root 3 and 3 identical. So divide it, 1, 1. 4 divided by 2 gives you 2. So the slope is 2. And as you anticipated, it must be 2 because the same points would form the same equation of a line. Then we use the equation of a line with slope point form, which means m is 2. And then for y1 and x1, you can choose either coordinates of point P1 or points P2. I'm going to use P1. Why not? So this is y minus the coordinates y1, which is 3 plus 2 radical 3, equals 2 is the value of the slope, x minus x1. So x1 from P1 is 3 plus root 3. Then you have to carefully distribute and combine like terms and say y is going mx plus b after that. So the first thing is to distribute this negative sign. So negative 3 will be shifted over to the right side. And negative 2 radical 3 will be positive on the right side because when we distribute, first you're going to get negative signs. And then each negative term, when shifted to the right side, will become positive. So distribute 2 times x and 2 times negative 3 and 2 times radical 3 right here. So you have 2x minus 6 minus 2 root 3 plus 3 from the left side plus 2 root 3 from the left side. Now combine like terms or cancel opposite terms. So negative 2 root 3 and positive 2 root 3 gets cancelled. Negative 6, positive 3 gives you negative 3, and 2x stays by itself. So 2x minus 3 is indeed the equation of a line that passes through the point of intersecting of that parabola with the given line. So hopefully this video makes sense. Now we know how to work with intersections of parabola and lines. If you put the equations together, create a new equations, simplify it, find a solution using quadratic formula, probably the best, most effective way of solving quadratic equations. And then there you go. Thanks for watching this video. Hopefully this video clarified this concept for you. Don't forget to do the practice question. Don't get too lazy. Share that video. We'll see you next time. Bye for now.